Here we are looking at example 10 from our 3-1-3-2 set of notes. We're asked to solve this system of equations. Now again, we're not told which method to use, so we actually have some choices here. In just looking at this particular problem though, I noticed that one of the variables is already solved for. So y is equal to 2x minus 3. And I'm thinking probably the substitution method is going to be the quickest and easiest because we already have a variable solved for. So we're going to go ahead and take this 2x minus 3, which we know is equal to y, and throw it into our other function for y. Because again, y is certainly equal to y. And we know that from our first function that y is equal to this 2x minus 3. So we can go ahead and substitute that 2x minus 3 in there. We then end up with 6x minus 3 times, instead of y, it's 2x minus 3 is equal to 9. Going ahead and distributing in our negative 3, we end up then with 6x minus, looks like 6x, plus 9 is equal to 9. Well, our 6x cancels out with our negative 6x, leaving us with then just 9 is equal to 9. And that's a true statement. 9 is, in fact, equal to 9. And this is always going to be true for no matter what x and y value you choose. So anytime you end up with a true statement like this is going to be all real numbers. And graphically what's going on there, bad graph, but you get the idea, is that we have some line. Let's say that this was our top function. And then for our bottom function, we have this other guy. It's literally the same exact line, and that's why it's going to work for any x and y value you choose, because they are literally the same exact lines. These equations are just written differently, that's all. Prime example is if we were to go ahead and just solve for y here to kind of prove that they are the same line. Oops. So we have 6x minus 3y is equal to 9. We would first subtract 6x from both sides, so negative 3y is equal to negative 6x plus 9, dividing both sides by negative 3. On the left, they cancel out, leaving us then with just y is equal to, looks like 2x when you divide those, because negative 6 divided by negative 3 is positive 2x. And then positive 9 divided by negative 3 is negative 3. So when we just simplify and put things into y equals mx plus b for our green equation, we see that they do in fact come out to be the same exact thing as our red equation. So they are in fact then the same line. But again, that is example 10 from our 3.1 and 3.2 set of notes.